On this Ram 1500 Classic with the 5.7 Hemi P0305 means the PCM has identified a misfire pattern on cylinder 5. The truck may run rough, shake at idle, lose power under load, or turn the MIL on or flashing if the misfire is severe. Broadly, this can come from ignition, fuel delivery, air leaks, engine mechanical problems, cam timing or valve train issues, wiring, or in the final path, the PCM. Start with the basic system checks and follow a structured diagnostic approach. The PCM is watching crankshaft speed changes to identify a single-cylinder misfire, and the monitor gates belong on screen. Fuel level above 12%, battery voltage above 9 volts, ambient temperature above -23 degrees C, -4 degrees F, coolant temperature at engine start above -7 degrees C, 4 degrees F, possible enable when engine temperature reaches 21 degrees C, 8 degrees F, and engine speed between approximately 400 RPM and 6,200 RPM. The code sets when crankshaft speed variation between cylinders exceeds the calibrated value for the current speed and load. Turn the ignition on, pull the stored codes, and record the captured operating conditions. Then drive the vehicle under the same captured conditions and pay attention to when cylinder 5 starts missing. Watch the downstream oxygen sensor behavior while the misfire is happening, and use the misfire monitor to confirm whether cylinder 5 is showing excessive misfire counts right now. A downstream oxygen signal staying low points toward a lean or lack of fuel condition, such as a restricted injector or fuel system issue. A signal staying high means the catalyst is being loaded with too much fuel, which can happen from lack of spark or a leaking injector. Also remember that during a severe flashing MIL misfire, the PCM can shut off the affected injector for a calibrated number of engine revolutions, so a high-speed or heavy-load misfire can look like it keeps going at idle until the counter resets. If cylinder 5 is not actively showing excessive misfires, treat it as an intermittent condition instead of forcing the rest of the test. Next, look at the codes you recorded. If there are active or pending faults in the fuel system, ignition system, air handling system, VVT system, or VVL system, diagnose those first because they can explain the cylinder 5 misfire. If none of those are present, the next return point in this path is unclear, so pause, recheck the earlier diagnostic path, and avoid guessing before continuing. Once the path is confirmed, do a broad inspection. Look for belt or accessory pulley problems that can disturb crankshaft speed, incorrect CKP, CMP, or MAP sensor mounting, poor terminal contact at sensors, the throttle body, injector, coil, and related connectors, corroded PCM power or ground circuits, vacuum leaks, air intake or exhaust restriction, internal engine issues, moisture on ignition components, fuel concerns, bogging, and towing overload. If you find a real problem, repair it as needed and verify the repair. If the inspection does not find a problem, again pause if the return point is unclear, recheck the earlier path, and do not jump ahead blindly. Now check the engine and intake manifold for vacuum leaks. A vacuum leak can affect one cylinder or several cylinders depending on where the leak is, so do not assume a single cylinder code rules that out. If an intake leak is found, repair the leak and verify the repair. If no leak is found, move to fuel quality. Check for water in the fuel, wrong fuel type, old or contaminated fuel, and low fuel. Also run the proper ethanol level check for the gasoline. If the fuel is the problem, replace the fuel and, if needed, flush and clean the fuel system, then verify the repair. Before fuel system testing, remember the fuel system stays under pressure even with the engine off. Release pressure before opening any fuel hose, fitting, or line. Install fuel pressure decay tester 8978A at the fuel rail. Turn the ignition on. Let pressure reach maximum and stabilize, and record that as the starting pressure. Actuate the cylinder 5 injector with the scan tool while watching the pressure gauge. Then record the ending pressure. Repeat the same test on several good cylinders, always starting each injector actuation from the same starting pressure. After each injector actuation, start the engine to clear fuel from the cylinder, skipping that can damage the engine. Compare the ending pressures. If cylinder 5 is about the same as the good cylinders, continue to spark testing. If cylinder 5 stands out and the pressure drop is too small, check for debris in the rail or injector and repair as needed. If the pressure drop is too large, suspect a faulty or fouled injector, then verify the repair path. Shut the ignition off, remove the fuel pressure decay tester and reconnect the fuel lines before continuing. Remove the ignition coil from cylinder 5, reconnect the coil connector, disconnect the cylinder 5 fuel injector connector, and install a spark tester on the coil. Crank the engine and look for a crisp blue spark. If the spark is crisp and blue, inspect the spark plug and cylinder. If it is not, skip to the coil feed and control circuit tests. With the ignition off, remove the spark plug and inspect for cracks, carbon tracking, oil fouling, coolant fouling, excess fuel, and out-of-spec gap or a loose or broken electrode. Also look for oil or coolant in the cylinder. If those plug conditions are present, replace the spark plug. If oil or coolant is present in the cylinder, diagnose and repair the cause, then verify the repair. If the plug and cylinder inspection does not explain the fault, run a compression test on all cylinders and compare cylinder 5 to known good cylinders. Compression or valve train problems usually show up across operating conditions, and the bad cylinder will often have the highest misfire count. If compression is not within specification, use a cylinder leak down test to decide whether the cause is in the valve train or combustion chamber. Repair as needed, and verify the repair. If compression is within specification, move the cylinder 5 spark plug to a known good cylinder, or replace it if access makes swapping impractical. Start the engine and watch the misfire monitor. If the misfire follows the plug, replace that spark plug and verify. If the misfire does not follow the plug and does not go away, clean carbon from the valve train and combustion chambers using MOPR combustion cleaner. After driving and clearing the cleaner from the engine, erase the codes, drive under the captured conditions, and watch the misfire monitor again. If the misfire does not return, carbon cleaning repaired the fault. If it returns, continue. Before going deeper, check engine oil level and condition, along with the mechanical and oiling conditions that can cause a misfire. Mechanical tolerances out of specification, oil pressure out of specification, low oil level, the wrong oil filter, dirty or deteriorated oil, contaminated oil, incorrect viscosity, or aerated oil. Missing these checks can lead to a wrong diagnosis. If any are found, repair as necessary and verify the repair. If not, check VCT solenoid operation. Reconnect the PCM-C2 connector, turn the ignition on, and measure voltage on the VCT solenoid control circuit at the solenoid connector. The VCT solenoid driver circuit is a 12-0-volt PWM circuit, so the reading should vary with the selected actuation percentage. If voltage is present and approximately matches the percentage selected, visually inspect the camshaft lobes, rocker arms, and springs for excessive wear or broken parts. If valve train damage is found, make the appropriate repair and verify. If nothing is found there, move to the related harness and connection checks. If cylinder 5 did not have a crisp blue spark, work the ignition coil electrical path. Keep clear of the fan, belts, and pulleys when the engine is operating, and do not wear loose clothing. With the ignition off, disconnect the ignition coil connector. Turn the ignition on, actuate the ASD relay with the scan tool, and use a 12-volt test light connected to ground to probe the ASD relay output circuit at the coil connector. If the light does not illuminate brightly, stop scan tool actuations. Repair the open or short to ground between the PDC and coil connector and verify the repair. If it does illuminate brightly, test the coil control circuit. Use a 12-volt test light connected to a 12-volt source. Back probe the coil control circuit at the ignition coil connector and crank the engine for 5 seconds. If the light blinks brightly, replace the ignition coil and verify. If the light stays on constantly, turn the ignition off. Disconnect PCM-C2 Install the GPEC Diagnostic 10436 adapter on the engine harness side and check continuity between ground and the coil control circuit. Do not probe the PCM harness connectors. That can damage the terminals and create poor terminal contact. If continuity to ground is present, repair the coil control circuit for a short to ground and verify. If there is no continuity to ground, continue to connector checks. If the coil control test light stays OFF constantly, measure resistance in the coil control circuit between the ignition coil connector and the GPEC adapter. If resistance is below 3.0 ohms, continue to connector checks. If it is not below 3.0 ohms, repair the open or high resistance in the coil control circuit and verify. Keep verification separate from the fault isolation work. For the final connection check, disconnect the PCM connectors, any related inline connectors, and the related component connectors. Inspect connector fit, locks, corrosion, water intrusion, seals, bent terminals, overheated terminals, push-back terminals, spread terminals, and terminal tension. Repair any condition you find. Then reconnect the PCM, inline, and component connectors, making sure they are fully seated and locked. Erase the codes. Operate or test drive the vehicle under the monitored and set conditions, and read the codes again. If P0305 returns after these checks, replace and program the PCM, then verify the repair. If it does not return, the wiring or poor connection issue has been repaired. The takeaway is simple. Prove the cylinder 5 misfire first. Separate fuel, spark, mechanical, VCT, and wiring causes in order, and only condemn the PCM after the path has been completed. For more diagnostic training, visit stepdiagnostics.com.